Hey everyone, welcome back. We are on slide 14 of chapter 24, the lymphatic system. We've talked about the primary lymphoid tissues, the red bone marrow and the thymus, where lymphocytes are made, B lymphocytes and T lymphocytes respectively. And then we've talked about secondary lymphatic tissues, where secondary lymphoid tissues, where you have these lymphocytes and macrophages doing their job. They are filtering out pathogens from fluid that's been collected originally from blood and that's filtered out of blood vessels into these regions, or they've come from regions where there's a high interface with the environment, like in your respiratory tract, urinary tract, digestive tract, reproductive tract, places like that. Now we're moving and talking about one more secondary lymphatic tissue, secondary lymphoid tissue, and it's at the junctions of certain lymphatic vessels, lymph vessels, and these are lymph nodes. Lymph nodes are junctions between lymph vessels. Let's take a look at this illustration down here first. What you can see is that there are some lymph vessels that feed in fluid, that feed in lymph into this node. That the lymph fluid can get filtered inside of this lymph node, and then the filtered fluid exits out a different lymph vessel. Here's a lymph vessel exiting its efferent. On top of that, you get blood going into and out of this lymph node. There are lymph arteries and veins. So it's an intersection of a lot of different fluids so that we can filter for pathogens. Lymph nodes filter fluid from blood that enters lymph capillaries. The region where blood vessels and lymph vessels enter and exit, take a look up here where it is colored in black. This is called the hilum. A hilum is a region where you have entry and exit of things like vessels, blood or lymph vessels. But you can see that arranged mostly towards the edges, but sometimes towards the middle, you have lymph nodules. We have lymph nodules, lymph follicles within the lymph node. Node is a bigger thing, nodule is a smaller thing. And as before, you have germinal centers, lighter colored germinal centers, where you have mitosis of lymphocytes. This lymph node, not shown in this staining, but shown below, bottom left. In this staining, we're staining specifically for the reticular fibers, those dark reticular fibers. So this is reticular connective tissue. Most of these lymphatic organs that we've seen, red bone marrow, spleen, thymus, they have reticular connective tissue. Reticular, there we go. Like I said, I want to point out again, a germinal center is where you have mitosis of lymphocytes, and that's happening at the center of these lymph nodules within lymph nodes and at the other lymph organs as well. Where can you find lymph nodes? There's a lot of them. They're found throughout your body, but they tend to be clustered in certain areas. They tend to be found in your neck region. So those are cervical lymph nodes. They tend to be found in your armpit region. Those are your axillary lymph nodes. And they tend to be found in your groin region, in your iliac inguinal lymph nodes. So they're mostly concentrated, as you can see. I mean, there's more, but they're mostly concentrated at joints. Major joints of your appendages, or joint with your head, or joint with your hips. At these regions, we're able to squeeze more fluid back and circulate it throughout. It's just a good way to, these are good literal intersection points to have fluid pass through. Lymph vessels, let me go back to slide 14. if you take a look at this lymph vessel over here, you can see that these lymph vessels have valves. Because the lymph that's flowing through lymph vessels, the pressure is very low, there's no heart pumping it. Lymph vessels need one-way valves, just like veins do, to keep a one-way flow of lymph fluid towards and keep it moving towards the heart. Lymph vessels in general are there to collect pathogens and proteins and electrolytes, those are just ions, and excess fluid that's run off from capillaries. In this picture at the bottom right in this illustration, blood flows through an arteriole. It goes to capillaries. There's our capillary. And then from capillaries, most fluid continues onto venules. That's the typical route. But some fluid will leak out. Some fluid will leak, as I'm drawing here in blue. Some fluid will leak into the interstitial area and then get absorbed by lymph capillaries. And that excess fluid travels in one direction towards the heart, back towards the heart. Specifically to a vein back towards the heart. There are different sizes of lymph vessels, just like there are different sizes of blood vessels. So the smallest lymph vessels are lymph capillaries, lymphatic capillaries. They are similar in some ways to blood capillaries, but some major differences. You can see examples of lymphatic capillaries outlined here in yellow. Lymphatic capillaries tend to be larger in diameter than blood capillaries. Blood capillaries are tiny. Like, I don't know that I can see it. Oh, here we go. There's a blood capillary. Whereas these, do it in yellow, these are lymph capillaries. They're larger in diameter, they have thinner walls, generally irregular outline, and they have a high permeability, meaning they can take fluid in more easily. If their job is to collect excess interstitial fluid, they'll collect it more easily. So let me show in this other diagram over here. Here we have a blood capillary, and then we get fluid, interstitial fluid forming, and that exits out of those lymph capillaries to larger lymph vessels. Larger lymph vessels are called, largest lymph vessels are lymphatic ducts. Lymphatic ducts, these are the ones that have valves. Lymphatic ducts have valves. You can see a longitudinal section right here, and the valve is visible in this cut. Lymphatic ducts, how do they differ from, say, veins, which are pretty similar since they also have valves? Lymphatic ducts have thinner walls and larger lumens than veins. Also, they don't really have layers. Veins, like arteries, have those three basic layers: tunica, intima, media, and externa. We don't see those distinguishable layers here with lymphatic vessels. Here's a nice illustration of differences between the three. Lymphatic vessels do not have layers. So just like a water treatment plant, our lymphatic system absorbs excess fluid. Take a look at this diagram over here. Let's start in the left ventricle. Here we are starting in the left ventricle. Fluid gets pumped out of the heart, out of the aorta, to the systemic arteries, we branch to arterioles, to capillaries. And we could keep going if most fluid will keep going, but some fluid leaks out. we've leaked into the interstitial fluid. Interstitial, spell. And that fluid, some of it stays in the interstitial area, but we want to absorb excess fluid. So some fluid will get absorbed by lymphatic capillaries. It'll pass through lymph nodes, continue onto lymph vessels, and we have valves here to ensure one-way flow. And that will get returned back to venous circulation, back to the heart. Now, this is just one simplified view of where it's happening. This is happening all over our body, in our heads, our arms, legs, everywhere. So, yeah, that is lymphatic circulation and the organs that are associated with it. Lymphatic system absorbs excess fluid, and in doing so can also transport nutrients, wastes, and hormones, and can filter out pathogens. And there's many ways we can do that, not just with lymph nodes, but also with tonsils, with mucosa-associated lymphoid tissues like Peyer's patches and what we have in the appendix and other places as well. All right, that wraps up chapter 24. Please let me know if you have any questions. Leave questions in the comments and the discussion. And yeah, have a good day.